welcome to today's class, and today's class we are going to discuss about network protocols and services. And before we begin, I think apology for we were to have some makeup classes, but I will still insist that maybe before the week ends, I will still have some makeup classes for the classes that we have not been able to cover since our class has been affected by the public holidays. So today we are going to discuss about network protocols and services, and we want to start with the objectives. So these are the objective of the course. You can see from what we have the network protocols. That's what we are going to discuss, and one of the objective is to explain how protocols enable network to operate. So explanation on how protocols operate. And then we'll have Ethernet and Internet protocols. So here is just, but you should be able to explain how Ethernet and IP protocols support network communication. So basically, we have got a list of subtopics there, so that you can be able to see from here. So I hope you are able to read from the screen, because I will not be able to read word by word each and every thing that is displayed on the screen, but I hope you can be able to see the objective of the day. So continuation, we'll have maybe connectivity verification. That this one is use common testing utilities to verify and test the network connectivity. So we will be able to use one or two tools to be able to test the connectivity between devices and be able to verify that the devices are working. And then we'll use what called ARP, that is Address Resolution Protocol, and explain how the Address Resolution Protocol enables communication on network. So let's see how far we can go, and I want to start off. And since this topic was a topic that we had covered in our CCNA, so I will not be getting into maybe very deep details, but I will just be brushing through some of the topics that we covered in CCNA. So remember, some of the topics are repeated here. So one is verifying, network communication process. That's where we begin. And here we want to start with the views of the network. So, and here we will here you are supposed to know the various types of the network. Like maybe we have got a small home network. Apart from the small home network, we normally have what called SOHO. SOHO stands for small office home network, like what we have here. That this one is a small home office network. And then we have medium to large networks, and we have the World Wide Web. So this is just the types of networks that we should be able to know. So that's not much. So then network communication process, how devices will communicate. So remember, we can have a client server, and we can have what we call a peer-to-peer. They are called what we call we normally call them they are called network architectures. Network architectures. I was looking for this tool which I'm using. So basically, network architectures, we normally have one of them is called client server model, and we have what called peer-to-peer. So like maybe for our case, we have got a file and client server communication, whereby server can store corporate and the user files, and then the client devices accesses these files with client software. So basically here we'll have what called a client software installed on this particular PC, and then we'll have the server. So the server has got all the centralized maybe storage of your files. So depending on which kind of the server you have. So the web server client, like maybe here we have got a web server. So remember, we have said we have got what called a file server. So this one is a file server. A file server is accessed by what called a file client. And a client should have a software installed on it. It's like maybe for those of you who have ever gone to a cyber. So whenever you are in a cyber cafe, so the machine that you are using has got a cyber timer, has got a software, a client software. And then we normally have a server. or even maybe a very good case example when you are doing your exam. I know you did the exam last week, so we had a server whereby all your files are stored, and we have a client whereby you are able to access using what we call a client. But for our case, we did not have a software installed. So this is a web client server whereby we can have a web server. So like here, this one is a web server. And then in our web server, we have got maybe a web client. So a web client is able now to to access a web server. Like maybe when you're accessing your email, there's a web server somewhere, like maybe Google emails. Although this one can be in a local network. And then we can have an email client whereby an email client has got a software that enables this email client to access the email server. So this one is an email server. So basically this one is that concept that indicates how the client server communicates. And you can use maybe various applications to be able to access your server wherever you are. We move on. A typical session, like maybe here, as you can be able to see. So this one is determine the origin of the traffic, enters the network. So for example, we have a student by the name Telly. Data follows with the data of thousands of other users along fiber optic network that connect Telly's ISP with the service several other ISPs. So basically here, it's talking about how students are able to generate traffic. So like maybe when you're in a campus. So when you're in a when in the campus, or maybe where you are at home, so we have people who are using different devices. We normally use the concept of BYD, bring your own device. Maybe somebody could be using maybe a mobile phone like this guy here. We can have maybe a tablet, somebody using a tablet, another one using a laptop. So they generate a lot of traffic. So then that traffic now enters maybe the company website, and then it's processed by the servers, and then that particular data is stored on there, maybe on the organization, like maybe the university. The university can be able to store the data of all the users in that network, and then stores them in that system. That's generally how the traffic can be generated in an organization. So I think we move on. I hope I'm able to. So I'll be checking I'll be checking your comments maybe later as we move on, since I'm not able to check your comments as I move on. So the other one is maybe like a gamer. So somebody who is playing games online. So this one is determining how determine the origin of the traffic enters the network. So like maybe here we have Michelle. Like many home networks, connect to the ISP using a router or a modem. These devices allow the Michelle home network to connect to a cable TV network that belongs to Michelle ISP. So basically, the Michelle is able to connect to the internet where the various devices are available, and she is able now to play a game online with other people. So the cable wires from the Michelle neighborhood all connect to a central point on a telephone pole and then connect to a fiber optic. This fiber optic network connects many neighborhoods that are served by Michelle ISP. So that's what will happen. So basically, this one is a typical example of how you at home you are able to play a game, and this one is a typical example of how the traffic can be generated and how the traffic is sent from your machine at home, how it's connected maybe via a telephone line, and then to a fiber optic cable that is next to your home. And then you're able to play a game with other people on the internet. So another one is a typical session, like maybe a surgeon. Determine the origin of the traffic enters the network. Like maybe here we have got maybe a surgeon, and the surgeon here is Dr. Ishmael, who is an oncologist, and he is able to perform what we call surgery and cancer to patients. He frequently needs to consult with the radiologists and other specialists on the patient cases. The hospital that Dr. Awad works for subscribe for a special service called Crowd. The Crowd allow medical data, including patient X-rays and MRIs, to be stored in a central location that is accessed over the internet. So maybe this one can be a multinational hospital or a hospital that is able to store their data in Crowd. And when they store data in Crowd, if Dr. Ismail would like to maybe check a patient data, he just logs into the company, maybe servers, and then he is able to get the data, or maybe the data could be somewhere online. And a very good example during this particular maybe COVID period, doctors in Kenya, they're able to share data with the doctors in Wuhan. I don't know whether you saw that case, whereby they have got maybe they're able to have even a video conferencing. And then maybe we have some online sessions whereby the doctors are able to share tips on how to be able to treat particular cases. Even the patients who are going for treatment in India, since they are not able to go for treatment, they're able to access some online services, and then they're able even to do consultation online. So basically that data can be stored over the cloud, and people can be able to access it. So we are using Cloud, and everything that we are doing currently is on Cloud. And I believe you have been using Cloud in one way or the other. If you have been saving your contact online, or you have been using Google Drive, so that's a form of Cloud. So it can be able to generate data, and people can be able to access that data. Okay, so this is our next slide. Tracing the path, and this one is just but showing us how maybe a path can be traced from one point to the other. So this one could be a structured kind of network. So cybersecurity analyst must be able to determine the origin of traffic that enters the network and the destination of the traffic that leaves. So understanding the path that the network takes is essential to this. So it's very important. So for you guys who are maybe trying to get into this field, so it's very important for you to be able to know how the traffic is moving from your network all the way to the other end. Probably you are communicating with somebody in a different branch. So it's very important for you. Like maybe we have tier 1 network and tier 2 networks. They connect to the exchange point, IXP. So I think we have somewhere we have got IXP. Let me have my pointer. So probably maybe we have got tier 1. I think we have a tier 1 network here. So this is the tier 1 network. So tier 1 network is able to connect through the EXP, probably through this network. Maybe here it's able to connect through this network. And large network connect to tier 2 network usually through the point of presence. We have got point of presence, POP. So this is a large network, tier 2. Tier 2, they now connect to what we call now to other network, to tier 3. So this one is now tier 3 here. We have tier 3 through what we call point of presence. Then tier 3 connects homes and businesses to the internet. So you can see maybe like now tier 3 now here. Tier 3 connect now to all these users. All these users are now connected via the tier 3. So this one is a tier 3. This one is a tier 3 device. Is able to connect the home users to tier 3. So basically, it's able to tell us how devices are interconnected with each other and how they are able to communicate. So basically, you are for your case is to being able to know which device is connecting to which. So maybe giving a very good example is our internet. So our internet is normally divided into what we call ISPs. So not ISPs. We normally have tier 1. So we normally have tier 1. So in case we are talking of internet, we have tier 1. We normally have tier 2. And we have tier 3. So that's how our internet is subdivided. So when you talk of tier 3 is just a very small ISP provider. So a small provider ISP. So a provider who covers the whole country. So we normally call them tier 3. Then tier 3 connects to what we call tier 2. Tier 2 now is an ISP that covers the whole of Africa. So and then tier 2 connects to tier 1. Tier 1 now covers the whole world. So an example is maybe a company like Verizon. Verizon is found in US, is tier 1. So another one is like Facebook and Google. They are also service providers, by the way. So they cover the whole world. Like maybe you can see we are talking of maybe some balloons which will be installed in Kenya. So which will enable people in remote areas to connect to the internet. So that's provided by Google. So Google is tier 1. And then tier 2 covers the whole of Africa. So maybe before the class ends, so I'll show you maybe how maybe our fiber optic is, I think I showed you, but I'll still show you again how our fiber optic cable is connected so that you can be able to learn about how maybe who is connected to who. So I'll show you that maybe before the end of the class. Can there someone to remind me? So moving on, this is our practical activity, verifying network connectivity using ping. And you can also be able to trace maybe server using traceat, and this will be your practical activity. So I'll send you this practical activity, and then you'll be able to do it at your own free time. So what are protocols? So remember, I've said this is just but a repetition of what we did in some of the topics. So remember that protocols are just but rules that govern how devices communicate with each other. And protocols, they can provide a means of means for computers to communicate over the network. So like maybe a protocol is just but defining maybe which data can be sent from PCA to PCB. And the network protocols, they dictate the message encoding. So how the message will look like, and how the format of the message will be, how the message will be encapsulated, and the size of the message will also be determined. There will be determination of the size of the message, and maybe the timings and how the message will be delivered. Okay. Network protocol suites. So this one describes precise requirements and the various interactions, and it can also define a common format and set of rules for exchanging messages between devices. So basically, we are talking of protocols, how protocols maybe work. Some common network protocols, I believe we know some common network protocols. We have got layer 1, layer 2, layer 3, layer 4 protocols. They are divided into layers. And for our case here, we have got HTTP, we have got TCP, we have got IP, and so many others. So basically, we have got a wide range of protocols. Okay, I think we can move on. So as I have said, that protocols are normally divided into maybe depending on which layer the protocol operates. Like for our case, in case we talk of TCP/IP, remember TCP/IP is a 4-layer. We have got the application, the transport, and the internet, and the network layer. So basically, the protocols can be divided to depending on which layer they are. Like maybe the application layer protocols. So these are all the protocols in application layer. And there are more than this. So we have the name system protocols, the host configuration, that is maybe they deal with like maybe assigning of an IP address, they deal with the booting up a machine. And then we have the email protocols. So like maybe when you are sending an email or receiving an email. And we have a wide range of them. We have maybe the file transfer protocols. I think there was one student who was asking me, how can I be able to transfer protocols? Okay, maybe how can I be able to connect to a device remotely and transfer files? So you can use FTP, TFTP. Plus, we also have some applications which are developed which can enable you to connect to particular system and be able to transfer files. And then we have the web protocols. Like maybe if you want to connect to a website, like maybe right now you're on our ZDS platform, we have got HTTP, HTTPS, and so many other protocols. So then the transport layer protocols, we normally have two. We have the UDP and TCP. And then we have the internet layer protocols. So we have got the IP, the NAT. Remember, you were taught about network address translation. We have the IP support, like maybe the ICMP. The ICMP, they are normally used when you want to test maybe connectivity between device. When you type ping, when you see maybe request timed out, those messages, they are called ICMP messages. And I believe we know the routing protocols, maybe like the interior gateway routing protocol and exterior gateway routing protocols, like maybe the distance vector routing protocols. One is EIGRP and the link state routing protocols, OSPF. Then the network layer, we have got the address resolution protocol, PPP, Ethernet, and interface drivers. So basically, these are the various protocols. So maybe for your own good, ensure that you know the port number. It is very important for you. Port numbers for each and every of these particular protocols, port numbers. Make sure that you know. If I talk of maybe, if I talk of HTTP, which port number does it use? If I talk of DHCP, which port number is in use? So your case is to go and research on the TCP and UDP port numbers. So it's very important for you. So the format, size, and timing. So this one describes now things to do with the format, maybe the size of the message and the timing. So the format will describe now how data will be encapsulated and how data will be decapsulated. Remember that we talked of encapsulation as adding of header information. Assume that maybe I have my frame, I have my data, I have my data. So this one is my data from here. So adding of this header information, that's what we are calling encapsulation. So probably I'm adding the source destination IP address. Source destination IP address. Okay. Source destination IP address. If I'm using layer 2, that is data ring, it describes the source and destination MAC address. So that's now encapsulation. Then when data gets to this particular end, so it must be removed. So this envelope will be removed. So the envelope is now there. The header. This header will be removed. So when this header is removed, we are left with now this data now. So that's now what you call decapsulation now. And the frames are normally broken down to smaller sizes so that they can be transmitted faster. So that's why you can see. So probably this is a frame, but the frame has been broken down to smaller compartments so that it can be transmitted very fast. And then when it arrives on this particular end, the frames now will be reconstructed. So the frame will be reconstructed again. So the maybe part 1, part 2, part 3, and then we have now the entire data. So it's for the purpose of ensuring that data is transmitted quite fast. And then when data is transmitted, it must be timed. When times include maybe like the access methods. Remember the access method here, we are talking of the random access, carrier, sense, multiple access with collision detection. For collision detection is for the wired, and collision avoidance, carrier sense multiple access with collision avoidance is for the wireless devices. Normally use carrier sense multiple access with collision avoidance. So those are the various access methods that will be used. Then we have the flow control. Flow control now will now determine how the two devices will determine what will flow on this particular network. And then the response timeout. In case the device does not respond within a particular period of time, it will be timed out for the purpose of security. So then we have the various types of maybe messages with their sent. Remember we have unicast. Unicast is one-to-one, and broadcast is one to all. So remember, unicast is one-to-one. I believe you can remember that. That's why I've said this is a repetition. Broadcast is one to many, and then multicast is one to several, or one to many. Like maybe here, this device can communicate with a few others. So a few others, like you can see. And the broadcast is one to all. So this is this device will communicate with all these devices which are here. So that's one to all. Okay, moving on. I am still checking. I think we move on. we move on. We are now on reference model. I think we remember the reference model. So the reference model is now the TCP and UDP. So how they are related and which protocols are found where. Like maybe for a case, we have got the OSI model. Remember we talked about the OSI model, and we also have the TCP/IP model. So it has got 4 layers. So the 4 layers of the OSI, the 4 layers are normally mapped to the 7 layers of the OSI model. And then these are the various protocols. These are the various protocols which are in use. So these are the various protocols. So and that's why I said you should be able to know which protocols work in which layer. So these are the various protocols which are found in each and every layer. So kindly go and expound on each and every protocol, and you can dig deep and maybe get to understand much more information. You can have a refer of probably from your CCNA1 notes and CCNA2 and also CCNA3 notes. They can give you much more detailed on this particular protocols and how they operate. But this one is just showing us which protocol is found where. Like maybe if we talk of the application layer, we have got HTTP, DNS, DHCP, FTP, TFTP, plus so many others. There are several, there are many, but these are the examples. The transport layer protocol, we only have 2, the TCP and UDP, and Ethernet protocol, that is the network. Now we have got the IP version 4, IP version 6, IGMP, ICMP, version 4, and version 6, plus wide range of protocols. And then we have got the network access. So we have got the layer, the layer 2 protocols. So like point-to-point, frame relay, and Ethernet. And so many others. So this is for our own consumption. During our free time, we go and have a brief a detailed maybe discussion on the same. So 3 addresses. So we are still on communication protocols, how the 3 addresses. So the important addresses here we are talking of protocol address. So one of them we are talking of the protocol address, like you can see here, protocol address. We will talk about network host address and the physical address. Okay. So and these addresses are found at different levels. So of maybe the OSI model. Like maybe for a case, when we talk of the physical address are the MAC address. This one, the physical address are the MAC address. So you'll find them at the data link, this layer, this at this particular level. And then at the network layer, you'll find the network host address, the IP addresses. The IP addresses, you'll find them at the network to enable network layer to communicate with another network layer. So like maybe I remember that to enable a router. So here I could be having a router. So to enable a router, so router A communicate with another router here. So these are two routers here. Router A to communicate with the router B. So there must be an IP address. So for a switch, maybe switch A to communicate with the switch B, there must be a physical address. So that's why we are talking of maybe the data link. Data link, we will find the switches here. And network will find routers, or what we call multi-layer switches. We have got switches which can work in layer 3. So then the network protocol address, network protocol or protocol address for our case. So you'll find that in the physical layer. So here the physical layer. No, not physical layer, transport layer I mean. So you'll find the protocol address at the transport layer. So we move on, and then encapsulation. Remember, we have said encapsulation is the process of adding of the header information. Why do we add header information? So that data can be able to propagate from source to destination. So like maybe for our case, the division of data into smaller pieces is called segmentation. So breaking of data into smaller pieces is called segmentation. Like you can see, this data has been broken down to smaller pieces. After data has been broken down to smaller pieces, so some header information is normally added. Like maybe if you go to transport layer, so a transport layer header will be added there. Then when data flows down to the network layer, now it is now in form of packets. Remember in transport layer, we call it segment. And then when data now flows down to the network layer, it's normally called packet. And the packet has got another header that is added, that is the network header, which has now been added. This one is the source and destination IP address. And then when data flows down to the lower layers, is now the frame now. And the frame, there is always the frame header. That is a destination and source MAC address. And then when data now flows to the physical layer, now to the media now, so it's in the form of bit stream. We normally talk of bit stream. This is what will be transmitted on the network. So basically, the process of adding all this header information, the transport, the network, and the frame is normally called encapsulation. Okay. So that is it, and I think we can move on. So I think this one now shows how our frames will look like, and I think I will open my Wireshark to show you a frame, probably before the class ends. I will show you a Wireshark. So this one is now the various headers which have been added. The Ethernet, remember, is a layer 2, this one is a layer 3, and this one is a layer 4. So depending on which layer. So these are the various headers which have been added. And this one is your data, so which is now called user datagram. And then when it goes to the TCP layer, it's called the segment. And then we have got the IP packet. And then we have got the Ethernet frame. So basically, this is talking about how the various fields are added, or the header information which is added to ensure data is able to propagate from one point to the other. So that's a repetition of what we have been doing. So sending and receiving of web pages. So how the web pages are sent, probably maybe from maybe a PC like this one. Probably the data is sent from this PC to this server. So how is this data sent? So we know, like maybe for our case, we'll have like maybe HTTP, which now is a protocol, the application protocol govern the way the web server and web client will interact. So this particular protocol will now determine how the client will be able to interact with the web server for our case. And then we have the TCP, which manages individual conversation. So the conversation between the server and the client will be managed by the TCP. And then TCP can be able to divide the HTTP messages into what called smaller pieces, which we have called them segments. Remember, we have segments, or maybe messages broken down into smaller compartments for the purpose of maybe transmission, so that we do not lose those messages during transmission. Because if the data is too huge, it cannot be transmitted. And then we have the IP. So this one is responsible for the purpose of maybe taking the format of segment from TCP and then encapsulating them into packets. So basically, the work of the IP now is to ensure that the data has now is able to propagate maybe on the network by ensuring that there is a source and destination IP addresses. And we know what is the work of the Ethernet. And this network access control is responsible for taking the packet from the IP and formatting them to what called transmitted. To formatting them into a way that can now be transmitted over the media. Now, converting data into what we call frames, and then from frames, we have got the bit stream, like what we saw in the previous slide. So basically, this one now explains the scenario of how data is sent from the source to destination. So this is now another practical activity on how maybe you can be able to observe installing and verification of MINET topology and capturing and analyzing ICMP data in Wireshark. So that's what will happen. I hope I'll have some few minutes of using my Wireshark so that I can be able to show you one or two things which I need you to know. So now Ethernet and Ethernet protocol. So let's go to Ethernet. Ethernet is normally defined in layer 1 and layer 2 here. So as you can be able to see from what we have, so the Ethernet is defined at this particular point. So at data link and the physical layer. And we normally have two protocols, that is the logical link control and media access control. These are the two protocols which are defined there. And we normally have standards, like maybe the data link is defined by a standard called 802.2, and then we have got 802.3 now that also defines maybe the other standard which is normally used under the Ethernet. So the two standards under Ethernet is 802.2 and 802.3. And the sub-layers that we have got logical link control, and media access control. And what is the purpose of the Ethernet layer? So the Ethernet layer is responsible for data encapsulation. So remember what we have said about encapsulation, and is also responsible for media access control. Media access control now is controlling how the device will access the media. So it's very, very important. So as we move on, so the Ethernet frame, how it looks like. So remember we said that an Ethernet frame, the frame size, the minimum frame. So when data is being transmitted, there must be a minimum and maximum. So the minimum frame size is always 64 bytes. Make sure that you remember, because you'll be asked. And the maximum frame size is always 1518. Also remember, 1518. So that's the maximum frame size, 1518, and the minimum is 64 bytes. So if the frames are less than 64, so what happens? They are normally discarded. They are normally called RAND frames. So they are normally called RAND frames, and the device receiving them, it discards them. And the device, the frames which are bigger than 1518, they are normally called jumbo. We normally call them jumbo frames. So when what happens to jumbo frames? The jumbo frames are discarded. So the two key identifiers, so we remember in Ethernet, we are talking of the frames. We have got the destination MAC address and we have the source MAC address, and it uses what we call hexadecimal. So the MAC address are in hexadecimal, and the MAC address size is 48 bits, 48 bits, and they are all in hexadecimal. And this one is the various periods of a frame. So moving on. So as we have said, the MAC address, I think you can go and have a review of this. The MAC address is always in 48 bits, and the MAC address has got two parts. One is maybe the owner of that particular device. So that's why the 24 bits. So the first 24 bits indicates the vendor of the device, and the other 24 bits is the device now. So the device is normally given a particular code. So I think that's a work that we can go and check. So like maybe this one is maybe a 48, the first 24. So the first 24, so is the vendor. Then this one is the device address. Okay, IPv4 encapsulation. So IP version 4 encapsulate the transport layer segment by adding an IP header. So basically, the layer 3 here, we are talking of this layer, the network layer. So this one network layer. So the work of the network layer now is to add another extra header. That is the IP header here. When the IP header is added now, it ensures data is able to propagate through the network. So remember these routers, the work of the routers to do the work of routing, to be able now to enable host A communicate with host B, and they could be in different section of the network. So you now use the routers. So routers depends on the IP header, this header now, to be able to route data, or to be able now to determine the best route to be used, depending on what information is on the IP packet header. Okay, I can see my time is moving very fast. So we can have somebody confirming for us when the session is supposed to end, because our session was starting at 9:05, and now the big blue button stops after 1 hour. Okay. So the IP version 4 characteristics. So this one is IP version 4. So remember the IP version 4 uses UDP. So when you talk of UDP, so UDP is connectionless. So meaning that a session is not established before the devices communicate. So we normally talk of connectionless. No dedicated end-to-end connection is created. Remember we have said it uses what we call UDP. So we do not have end-to-end connection. So since it uses UDP. And if you remember the characteristics of UDP, you're able to know about the IP. So one is connection race. So it's unreliable meaning that it uses what called best effort. So best effort is whereby if this host want to communicate with this host, there could be several paths. The first path, the second path, or maybe the third path, the fourth path. So there could be more than one path. So and it's unreliable because it uses best effort, meaning that you can send several packets. Like maybe here you can see all these packets, 1, 2, 3. But how many packets arrived? Two, meaning that it's unreliable. It's media independent. When you talk of media independent, so like maybe for a diagram that you can see here. So here, this one is Ethernet, this one is CDO, this one is Ethernet, this one is Ethernet, this one is wireless. So meaning that you don't need to worry about which media you are using. So meaning that the IP is media independent. So moving on, so the IP version 4, I had how it looks like. This is how the IP version 4 looks like. This is how it looks like. And I think I will do a demonstration. So you allow me to maybe pause for 1 minute. I open my Washak since I need to show you one or two things before my session ends. So we can have maybe I'll pause my recording for 1 minute. So I've said we go to our, so here I am. So this is my Washak, and I need now to see how our frames look like. For those of guys who cannot remember how our frame look like, so whereby we have got all these fields. So the Ethernet, remember we have the destination and source, and then we have said the type. Probably here is IP version 6, which is inside, and then we have got layer 3. Layer 3 we have said is normally internet, and here we have got IP version 6. So you can see we have IP version 6. And for those of us who do not know the various fields of IP version 6, so these are the various fields of IP version 6. So the version, then the traffic class, then the flow label, the payload length, the next header, the hop limit, source, and destination. So let's see an IP version 4 because we were to see a header of IP version 4. So this is a header of IP version 6. It has got these fields. So and then I think I wanted to see an IP version 4. Let me just capture one. Let me see whether I can be able to see any of this. I will just check from my Washak. I will just check randomly. I think all these one I can see they are using IP. I'm using IP version 6 continentally. This TCP. Let me just go to TCP. You can filter here. You can filter to IP. Let me filter IP. I don't know whether you can filter. Let me filter TCP. I'll filter TCP, and then after you filter, you click apply. You can click apply. So when you click apply, so this one is you only get the TCP. So you depends on what you want to filter. So if I now go to TCP here, I have now IP. Let me see whether I have IP version 4. Perfect. I have the IP version 4, the one that we saw on our nodes. So this one is IP version 4. So the header that we saw, what we saw there in the form of a diagram. So I have destination, address, which is this one. Okay, no, not there. That's that's an Ethernet. So I want to go to the inner header, that is a version 4 IP. We have the header length is always 20 bytes. Make sure that you remember that the TCP header is always 20 bytes. The differentiated services, the total length, identification, the fragment offset, time to leave, protocol. Then we have the checksum to check for errors, the source and destination, address. So remember the address are here down. Yes. So as you can be able to see from the diagram, so this is the diagram that you are seeing. So here, version, so Ethernet length, differentiated services, which the other fields here, total length, identification fragment offset, time to leave, protocol, header checksum, the address that we have seen. So this is now the IP version 4, which we have seen it here. Okay. Now I think I don't have maybe the other one is if now maybe I go to my if I go to my device, let me go to my device. I open CMD. I'm hoping I'm still within my time limit. So if my time is up, Henry alert me because I think our time can. So I can go to maybe let me ping 8.8.8.8. So I'm pinging Google for your case. So I'm pinging Google. So these are called ICMP messages. For those guys who do not know, these are called ICMP messages. If I go to my Wireshark, so probably I can capture again. Let me just capture. I'm trying to capture again. Yes. And then maybe I go to the interface. I will specify the interface here. So maybe from here, I can stop and then I can start again. So let me start. Continue without saving. So, and when I start, I need now to, I was pinging Google. So let me ping, I'm pinging Google. So let me ping again. So I'm pinging Google. So I'm generating ICMP messages. So these are called ICMP messages. And if I go to, let me see, this is an application which I opened. So I think I do not have ICMP. You can filter here, ICMP. If the ICMP messages, you're able to see. Remember, we have ICMP for IP version 4, you just call them ICMP. And you also have ICMP for IP version 6. It's called ICMP v6. So you just go to this and then apply. If there are ICMPs, ICMP, then I'll apply. If they are there, perfect. I have them. So this is like when I was when I typed ping, like maybe you can see this is what I was pinging. So when you are pinging, you are using what called ICMP messages. And the ICMP messages, we have said they are normally used when you are testing connectivity between devices. You can see. So here, and this is how the ICMP looks like. Like maybe probably I can just double click on one. Yes, this is what this is how it looks like. An ICMP. So let's see, ICMP is here. So ICMP has got the type, the code, checksum, identifier, sequence number, and then we also have sequence number. So basically the type code. So the code which is used to send maybe like an echo request. So like I have it here. Okay, that's it and done. I think that's about the ICMP. Then let me go to something else. Just allow me to be flipping from one window to the other so that I can show you one or two things. So this is one of the practical activities that we are supposed to have done. You test connectivity between devices. When you test, you are generating what called ICMP messages. Going to my browser, so I had said that maybe I wanted to show you what called the service providers. So the service providers in the world, we normally have I think my class, I really do not like maybe just dealing with what is there in class, so like exploring. So that's why, so like maybe here, when I talk of service provider, so I talked of tier 1. So let me use my highlighter here. So I think I can, oh yeah, I wanted to go to Africa. Yes, perfect. So I was, as I taught you last time when we were in class, I remember for this class, I think I had taught them. So about the service providers, we normally talked of tier, tier 1. So tier 1 and tier 2 and tier 3. So like we said, since maybe Safaricom and others, they only cover the whole country. They only cover the whole country like this. So we call them tier 3. Now tier 3, you can see all of them. They get internet here from Nyali, somewhere in Nyali. So somewhere in Nyali. If I happen to zoom much, if I zoom inside, or I'm zooming out, if I happen to zoom inside, so this one is where we are tapping our internet. So our tier 1 will cover the whole country. Any of the providers, either maybe Access Kenya, either maybe Safaricom, they are called tier 1. Then tier 2 covers the whole of Africa. Let me zoom out a bit. The whole of Africa. So the whole of Africa. One cable here. I was in Nyeri some few years ago. So that's why I'm talking from experience, from the expert's point of view, from what the expert says. So from nearly here, we have one of the cables, and they are normally, it's normally one. It's normally several of them. So why we have several of them is such that in case one fails, the other one can pick up. So we have one cable going this way. So I hope my session is still on. So going this way. So we have one cable, and there are three of them in number. So going all the way like this, coming back. And then another one starting from here, going this way. Going this way. So it's normally a tier 2 service provider. So that's what you should know. And why we have more than one cable is that some of the cables, they act as backup. Another one maybe can be used to carry maybe some maybe like other signals, like maybe power. So basically that's tier 2, and then tier 3, tier 1. Tier 1 covers the whole world. So let me go going back. So tier 1 now covers the whole world. Like right now, you can see a service provider now who is covering between continents, like maybe this continent, maybe between here to here, between maybe Europe and Asia, maybe between Europe and Asia. You can see there are cables which are crisscrossing. So these are for tier 1. And we have several companies which are involved in laying down these cables. One of them is called Huawei Marine. Another one is called Equinix, and we have Verizon. We have so many other companies which are involved in laying down these cables. So you can go check maybe about tier 1, tier 2, and tier 3 service providers so that you can be able to understand much better. So that's it and done. I think my activity is done for today. So maybe to show you much more on maybe as I come, since I may not be able to wind up. So if I go back to what I was doing, maybe I can capture again. So let me capture again. So if right now I want to capture and be able to know what maybe that particular, let me stop. You can stop first and then you start again. And then you can save or continue. For my case, I want to continue without saving. So now, I think for my case, my Washak seems to be, so stop. I think I need to start. You can see what I'm doing. So my Washak seems not to be populated, but just in case it's populated, so I would have shown you how you can be able to capture. Maybe to see maybe for those guys who want to become security analysts. So I'll show you next time how you can be able to see maybe a username and even a password for a particular data stream that you want to follow. So that is it. I think I can see my time is far much gone. I don't know how many minutes we are left to wind up this particular session. So probably somebody can confirm for us. I think okay. So probably because of time, I think I need to be stopping because I started at I think I need to be stopping for now.